So the key for quiz 5. So this one is a classic kind of. Actually, this is like an SN1. That's what this is, an SN1 reaction actually. But either way, leaving group is going to have to leave. So you have the phosphorus, H plus. So you're going to protonate. Leaving group leaves. You're going to make a secondary carbocation. There's some resonance, it says, so pi bond moves. And I knew it wasn't this pi bond because if I looked at the product, I could see where this is going to end up. Right? Solvent adds. Solvent adds, proton transfer, regenerate the catalyst. And the other thing you made along the way was this pH3. That's what you made. And for the second one, E2 reaction. I tell you have to do a ring flip. We should know already they have to do that because bromine is equatorial. It needs to be axial, right? So I do the flip. So I pull this up, pull this down. Bromine gets axial. Now I need to look for beta hydrogens that are also axial, but this bromine's up, so I need to look for beta hydrogens that are axial down. So there's one on carbon 2. There is also ones on carbon 6, but carbon 2, if I do the elimination here, I get a tetrasubstituted alkene between 1 and 2, which is more substituted Zaitsev rule. So I could either draw it like, you could draw it like this or like this. Again, E2, 3 arrows, 1 step, bulky reactive base. There you go. All right, so this one, we got our steps. I got the product. First step's gonna be proton transfer, right? Then we have a leaving group leave. So also need to recognize this is telling us is E1. So in E1s, when you form a carbocation, there's 2 ways you can form a carbocation. You have a chlorine, a bromine, or iodine, and those can just leave. The other way is you have something with lone pairs and you protonate it with H+, or a strong acid, and that makes it a better leaving group, and then that leaves. So that's what this is. That leaves. We get a secondary carbocation, but we're going to do a rearrangement, right? Because now we're going to get a secondary allylic carbocation, so that's why this takes place. Make sure you show the electrons move. Never plus charges don't move, electrons and atoms move. Then we do our E1 elimination. H plus just falls off, right? Catalyst, regenerate the catalyst. Proton transfer, elimination, regen catalyst. Falls off, get the pi bond. But again, E1.